Hello, welcome to Governor Mifflin Coding Club. This is Lesson 2, Advanced LED Control. Now if you watched Lesson 1, we demonstrated how to control LEDs, flashing LEDs, turning them on, waiting for a moment, turning them off, waiting for a moment, and basically going through a number of different LED colors. Now what we're going to introduce today is another component that can control the LEDs, which is going to be a variable resistor. And that's going to be kit number 2. So if you pull kit number 2, what you'll see in the kit is the pre-wired SparkFun LED display. So everything's pre-wired for you. There's actually no other components in there that you can move around. But we'll have the same as Lesson 1. We'll have the 4 LEDs wired, and we have a potentiometer, again a variable resistor in there, and that'll change. That'll have an input signal into our arduino, which will then in turn control our LEDs. And today we're going to show you how to program that. Also in your kit is a form that tells you specifics as far as an analog input, pulse width modulation, and variable resistance, which is what we're going to demonstrate in this video and in this lesson. So to follow along, what you want to do is read through the concepts of the lesson itself. So let's get started programming. Now again, if you were in our last session, we had a program called Basic LED Control, and which was built off of the Blink program. Let's pull that back in here. Now if you'll notice, I'm gonna plug this thing in. There we go. Sorry about that. Okay. Alright, looks like we didn't change it from the last time around. So it's actually running the Blink program, and it's running actually the modified Blink program where it's flashing the 4 LEDs in a row. But we're going to change that. So again, this is our last lesson, the program that we had basically flashing the LEDs. And let me get rid of that. And that was our initial modification. Now what we did do was we did change the pins. So the pins are slightly different on this demonstration. So if you'll remember, we had variables at the very top here that we changed. We identified pin 13 as the blue LED control, pin number 12 as a green LED control, pin number 11 as, number 12 as the green, 11 as the yellow, and 10 as the red control. Now, in this series, in this program, we've changed it basically because the pulse width modulation, if you look on the board itself, disappear for a second here. Look at a pin for itself. 13 and 12 do not have pulse width modulation associated with the pin. And you can tell is the little squiggly lines aside of the pin number tells you that it is pulse width modulation control. Now what pulse width, get back into this frame here, what pulse width modulation is a series of signals. So if you get a signal coming from your computer, it's on, off, on, off, on, off. Well, pulse width modulation modulates that on, off to control your LEDs. Now, what we did was we put the blue LED on a pin 11. We put the green LED on pin 10, the yellow LED on pin 9, and red LED on pin 6. Again, as we mentioned in the first video, the lesson 1, if you put variables at the very top here and you change your program, we can simply just change the pin numbers and you're off and running. So let's see, we're going to continue on here. The void setup is going to be the same, but we do need to define our potentiometer that we entered into. We'll need to enter our potentiometer into our declaration of pins. So our potentiometer is actually connected to analog pin A0 over here on the board itself. So we're going to say constant int for integer, and we're going to call it pot pin, and we're going to make that equal to A0. Define constant potentiometer on pin A0. Okay. And I forgot my semicolon behind the line of code, so it doesn't read that. Next variable we want to put in is a pot variable. So the potentiometer is going to be, we're going to use that as a variable as well. So pot value is the pot value. Now we're not going to put a number behind that. And we'll just comment that as define a variable to hold the I spelled that wrong. The analog value of the potentiometer. Okay. Now the void setup itself is going to be the same thing. We're going to have the blue LED as output, have the green LED as output, the yellow LED as output, and the red LED as output. Now on the void loop, where we're putting our program itself, again, if you didn't save your program from lesson 1, just take your time and retype the program here. Declaring the variables, declaring your pin mode, and then down to the void loop. Now what we're going to do in the void loop, we're going to get an analog signal from the potentiometer. So how we're going to read that is, what we want to do is read potentiometer value, and how we're going to do that is pot value is going to be equal to analog read, and I spelled that wrong, didn't change color. Okay, analog read, and we're going to take it from the pot pin, which is A0. Okay. Now, what we're going to use the pot pin for is we're going to use it as the delay. So the pot value, we're going to put it in instead of 1,000 milliseconds, we're going to call this pot value. And that will change the delay of the blue LED. Okay. And for that matter, we will change that on every one of them. Oops, value, and this delay we're going to change to same thing, and the last one. Okay, so let's compile the sketch, make sure we have, oh, I spelled pot value wrong, so change that, capitals letter instead of a lowercase. We'll check that again, and it's done compiling, and everything's green, everything's good. So let's upload this to the Arduino. Oh, we want to double check our board, COM12. Let's try that again. It's uploading. Done uploading, so everything looks good here. So what the potentiometer does is going to read the signals into pin 0, A0, and from there it's going to change the speed of the LEDs. So if it turned all the way up, it's just solid colors. So there. And the frequency gets lower and lower and lower as you reduce the potentiometer. In fact, we'll turn it all the way down to 0. The delay is about 3 seconds, I guess, 2 seconds. And I'll turn it back up again. Actually, if I turn it all the way up, it's still flashing. It's just flashing so fast that you can't see the changes. Let me turn this down again. Okay, and that is potentiometer control of the delay. So very good. Okay, the next thing we're going to look at is using the potentiometer to change the brightness of the LEDs. So everything's going to be the same. We're going to change the constant slightly. So let's get over here to the program itself. And pot pin's going to be the same. So the potentiometer is still going to be an A0. Pot value is going to be the same. What we're going to do is we're going to change the analog read to brightness, though. So INT, we're going to call this brightness. And we're not going to put a value to it because that's what we're going to get from the potentiometer. Define brightness. Okay. Now on the analog read, when potentiometer is read by the analog read, it goes from 0 to 123. So as it reads numbers, it's going to divide to 123. So the potentiometer is a 10K potentiometer, but when it reads your signal into the A0 pin, again the separation is 123 separations. Now on the pulse width modulation, on the output, if you can see that, the output pins, they're digital. So the pulse width modulation goes from 0 to 255. So what we're going to do is map the input of the potentiometer and map it to the output of the LEDs. Now how we can do that is a function called the map function. Now this part's going to be the same, so I'm going to get rid of the delays because we're going to do something different here. So the analog read is going to be the same. We're going to read the pot value as the analog read equals to pot pin. But what we're going to do is we're going to make the brightness equal to a map function, which is going to be the pot value. So the potentiometer input is going to come in as the number, as your value, and that's going to go from 0 to 1023, and the output's going to be from 0 to 255. And get my semicolon in here, and put a comment in here. We're mapping potentiometer value to PWM output. Okay. Now the next thing to do is to actually turn on your LEDs again. Since we deleted all the digital writes for the LED, we do something different. This one is called analog write. An analog write is going to, instead of going from a digital write only goes to 5 volts. An analog write will go from 0 to 5 volts, and that's going to change the brightness of the LED. So let's do analog, if I can spell this correctly, and it turned green. That's correct. So analog rate, of the blue LED, and the value of the analog rate is going to be brightness. I'm going to comment this as turning on blue LED to potentiometer value. Let's do it that way. That sounds good. And we'll do the same thing to the green LED and the red LED and the yellow LED. Yeah. No space. What did I spell wrong there? No capital. There we go. Yellow LED. Too many O's. Brightness value. And the last one is the red. And we can comment these. Turning on green LED to pot value. And for the red one too. Okay. And close bracket there. Now again, let's review this. So our blue LED, green LED, yellow LED, red LED have not changed as far as the pins go. Potentiometer input is going to come from A0, which is still there. The potentiometer value is a variable, and we've initialized a brightness value. And we haven't changed the pin outputs. All the pins are still outputs as far as the green, yellow, and red LED and blue LED. Now, when we change the, what hasn't changed from what we did before was the analog read is still going to read a value from pot pin. What the difference on this program is we're going to make a value of brightness and map it to the pot value, which goes from 0 to 123, and that's going to be a 0. And then the output is going to be, I forgot to close bracket. The output is going to be through a pulse width modulation, and that value is going to be 0 to 255. So in essence, in the analog write on the blue LED, the brightness is going to be from 0 to 255, green is 0 to 255, yellow is going to go 0 to 255, and we're going to change that with a potentiometer. Theoretically, hopefully it works. Let's verify the sketch, make sure it compiles correctly, and we did something wrong. Green, oh, spelled green wrong. Okay, let's change that. Compile again. Excellent, no errors. Let's upload to the Arduino and take a look, see if our expectations are going to work correctly. Now, let's change the, I'm going to slide this over here so I can reach it. There we go. And everything works. As I turn the potentiometer, it brightens, and as I turn it down, it dims. So that's the variable control using a potentiometer to control the intensity of the LED. So that actually works. Applications of that are obvious. You can actually dim an LED, but also as outputs for like electric motors and whatnot, the variable output can control the speed of a motor as well as the brightness of an LED. So those are applications that we can move on to using a potentiometer. Okay, that concludes lesson 2 of advanced LEDs. If you have questions, certainly ask your instructor. Come back again. We will continue on with lesson 3. Lesson 3 will be about RGB LEDs and how to control RGB LEDs. Also, just as a reminder, when we write our programs, or if you're following along, save your programs because we are building upon programs from our previous lessons. Thank you again, and see you later.